highly recommend you do not even bother to figure out what that is. I think in web work it asks you to put in exact answers, so that means it wants the square root of 34 as part of your answer. So, now what? Sine of x. I should be able to do that, right? What will the sine of x be in this problem?
3 over the square root of 34.
3 over the square root of 34. All right. What about this one? Cosine of y. Is that going to be 5 over the square root of 34? Some people are going, no. What about the rest of you? Hang on, hang on. Is that going to be 5 over the square root of 34? Why not? Why not? I went to a different angle. You gotta watch. Adjacent and opposite are relative to where the angle is. This first problem, I have the angle down here at x. Now, in the cosine, what I'm asking about, y. So it's this angle. What becomes the adjacent side to the angle y? The 3. Hypotenuse doesn't change. So the sine, excuse me, it's cosine. The cosine of y is going to be, once again, 3 over the square root of 34. By the way, do you need to do this every time you have to answer a question? No, once you've done this for the problem, you can feel free to label it on your triangle, and then one time is enough, and then you can start using it. It's not like you have to do it again because we have another question. It's the same triangle, once is enough for the triangle. Kate?
So we don't need to rationalize it?
No, I don't insist that you rationalize these.
Okay. My teacher last year
I know, so there are some people who think rationalizing is a good thing, and you do use it later, but the main reason for rationalizing denominators was to make it so you could calculate what these values were on a slide rule. How many of you have one of those?
What?
You do? I own one. Okay, we got 2 of us. Do you know how to use yours?
Nope.
Me neither. I have the book from like 1930. So I don't see that it's absolutely necessary in this class.
Okay.
So if you want to, feel free. If you don't, I don't care. And web work doesn't either.
It's like weird when I see it on the bottom.
Well, so feel free to make it not seem strange to you. What's the tangent of x? Got 2 votes for 3 over 5. What do you guys think? Yeah? Going for that?
Yeah.
And back to having x, so it was the opposite over the adjacent, so 3 over 5. So yep, I'm going for 3/5. See, that's not hard.
You get those triangles where like you know the last side, like a 2, 4, 5 or something like that?
I usually avoid those. Mainly because people just automatically, so like this one for instance, people automatically put a 4 on the hypotenuse, and it's not the one that's 4. If you do get a 3, 4, 5 triangle, you have to solve the other side. I know some of the web work problems have them, but I avoid them on a test just to avoid having people do that without doing the work, because they lose points for not doing the work that I expect to have done. What's my cotangent of y? 5/3. Now, I have a question. 5/3?
3 over 5.
Cotangent of y? 3 over 5. Now, I have a question about the relationship between angles x and y. What can you tell me about them? No, they're not. Together, they equal 90 degrees. X plus y is going to be 90. We know that. We don't know what x is, we don't know what y is, but together they have to be 90 because all 3 of the angles in a triangle add up to 180. We've got 90 of them down here in the right angle. So this will give us some of our co-function identities. We call them identities. Co-function identities. So since x and y add up to 90, then the sine of x is the same thing as the cosine of y. And I'm trying to remember if that's the next thing I put up here or not. No, we have those two, we're gonna ignore those. Yeah, here they are, cofunction identities, are you ready? The sine of x is equal to the cosine of 90 minus x. Well, that's what this was. Here was the sine of x. Y was the same thing as 90 minus x, so the cosine of 90 minus x would be exactly the same. By the way, you don't use these very often, most of the time you don't need them. Same for cosine. The cosine of x is the same thing as the sine of 90 minus x. So, okay, this was y, but same process. Because the two angles added up were in the same triangle and had relatively the same sides related to each other. Now, another pair of cofunction identities works for tangent and cotangent. The tangent of x equals the cotangent of 90 minus x. And the cotangent of x equals the tangent of 90 minus x. And you want to guess where the last two come from? What the last pair is? Secant and cosecant. Yep. No, they're slow. The secant of x equals the cosecant of 90 minus x, and vice versa. The cosecant of x equals the secant of 90 minus x. The main reason I made sure to throw these in is later on in at least one of your web work problems, this comes up in getting to the answer. It's really annoying. If that weren't there, I probably wouldn't care. But it's one of the standard web work problems that came in. Now, finish writing. Now, how many of you, when you learned trig before, because I know lots of you had special triangles? So do you guys remember those special triangles? What were they? So one of them was 45, 45, 90. So this was 45, this was 45, and then the other one is, okay, we're going to pretend this looks like a 30, 60, 90. Which one's the 30? The small one. 30, 60, that's the 60. Okay, what did you do with the special triangles?
1, 1, root 2.
Yeah, this one, if we had the sides of length 1 and 1, then the hypotenuse was the square root of 2. And what about this one?
That's the 3, 4, 5, right?
No, it's not the 3, 4, 5. It's 1, 2, root 3. Where do they go? Well, which is the shortest side? Because that obviously has to be 1. The one over here, opposite to the 30-degree angle. All right, what's the next shortest side?
Root 3.
It's on the bottom. Is that going to be the 2 or the square root of 3? Square root of 3, because the square root of 3 is less than 2. And then that means this one must be 2. If you have these already memorized, feel free to use them, but use them correctly. So, for example, in this problem, where you're told beta is 60 degrees, if you are going to use what you know about these triangles, you have to make the right ratios and then solve for the appropriate sides. Otherwise, you can just use the stuff that we have and the fact that there are some cosines in there. So, I am going to do it not using the special triangles because more often than not, I've found that students don't remember the special triangles that well. And so instead of doing it with those, I prefer to do it without because you remember the rest of it. So in my triangle,